Okay, we'll do a few more. This one is number 37, which has to do with the formula that they give you, and we've just got to figure out really what's variable and what's constant on it. I hope you noticed the next time you're in a car, that when you're going around a curve, those engineers, when they put down roadway, they have to bank it a certain amount so that cars don't just go sliding off, which is kind of cool. So for 37, we're given that let's see, we're given that the velocity, yep, all right, so the velocity squared has to be in this particular relationship. So this is Rg tan theta where this is the banking angle. This is the radius, and we're given that this is the radius of a circular arc. So we know that in a circle the radius doesn't change, the radius stays the same. G is acceleration due to gravity. So really the only variables we have are here. This is a variable. Radius is constant, and acceleration due to gravity is constant. And the only other variable we have here is the angle. Which is nice, because if I'm multiplying by a constant, when I take the derivative, I can just leave this alone. Okay? So the question here is asking to find the relationship between the related rates dv dt and d theta dt. So a couple things that we know. We know that the radius and acceleration due to gravity are constant. Acceleration due to gravity is 32. So we're really just going to take the derivative with respect to time of v squared, which is equal to Rg tan theta. This is a variable, so when I take the derivative, this will be 2v is the derivative of the outside function, and then times dv over dt is going to equal this part, remember, is constant. I'm going to put parentheses around that just so we can think about that as a constant. A constant number times a constant number is just going to give us a constant number. So this is going to stay out here, so we're going to have Rg times this derivative. So the derivative of tangent of theta is going to be secant squared theta. And then we've got this inside function of the angle depending on time. So that's going to be times d theta over dt. And so we have two questions that we're answering in here. One of them is, what is the relation between dv dt and all of this stuff? And what is the relationship between d theta dt and all of this stuff? So part A, I'm just going to divide both sides by 2v. So dv over dt is equal to Rg secant squared theta d theta dt, all divided by 2v, at which point we could put in the 32 for the g, and it'll look a little bit similar to what they would have had in the back of the book. To get d theta dt alone, you're just going to divide both sides by Rg secant squared of theta, and then you'll have d theta dt alone. I hope that helps on 37. We'll switch to 35 in just a sec.